Clonezilla live on RISC-V, crafting open source live systems for open hardware.
Okay. Thank you for coming. Yeah, that's our talk. It's not easy to see here. Okay. Actually, for the RISC-V, it's an open hardware, right? So we will have more introduction a little bit later. And Clonezilla Live is a live system. It's based on Debian. So it's an open source software. So it's an open source on open hardware. This talk is about this. Okay, so that's the outline for the talk today. The first one is an introduction to Clonezilla. The second one will be RISC-V architecture, and the third one is Clonezilla Live for RISC-V, and the future outlook and the question and answer. So that's the first one. Okay, very short introduction. Before I start, anyone here used Clonezilla before? Maybe raise your hand. Okay, about 1/3. Okay. All right, so it's a tool for you to do the system image and cloning. Okay, you can do the backup, you can do the massive deployment. Okay, especially when you want, just in case your system will be broken, then it's better to back up your system. That's the main purpose for Clonezilla. And for the massive deployment, it's something like this in a computer classroom in the right here. And you want to do, clone a temporary machine to the rest of the computers in the computer classroom. And also, so you can do like this to clone, you want to distribute the data or some live system to your friends or your students, something like that. Then you can use Clonezilla Live to do this kind of basic deployment for the USB flash drive. And also in the machine room, you have some servers you want to do the basic deployment. So that's the scenario for Clonezilla. And come on, why? Okay. And basically, Clonezilla is a GPL license. And the live system, we actually combine the Clonezilla software with Debian or Ubuntu as an underlying operating system. So you can use this tool to do a bare metal recovery for Linux, Mac OS, Windows, BSD, something like that. Okay. All right. So let's come to the open hardware RISC-V architecture. This will be a very short one. It's an open source. Basically, the license can be a Creative Commons or BSD for RISC-V. Okay, it was introduced in about 10 years ago, 11 years ago, it's 2014. So as you can see nowadays, actually, some of the small board or some of the laptop, actually, you can have a RISC-V architecture. And in the beginning, it was from the UC Berkeley, and later it transferred all the RISC-V to the RISC-V Foundation, and in the end, now it's a RISC-V International in Europe, actually. The headquarters there. There are many vendors because it's open hardware, open source. So some vendors like Sci-Fi, Andes, Ventana, blah, 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 many, really. A lot of in US, in Taiwan, or in China also, because, open hardware will be easier to cooperate with. So there are many vendors, they are working on this. And for the kernel official support, it was in 2022. And Debian, the underlying operating system we mentioned for the Linux is Debian, and it supports RISC-V from 2023. So last year we tried to port Clonezilla Live, the whole system, to RISC-V. And later we'll have some more details why we want to and why how we did that. This morning someone asked us why you want to port Clonezilla to RISC-V. Linux should work on all the RISC-V machine, something like that. But actually, basically yes. But the reason why we want to do is really because it's for fun. We like to have this system ready. Clonezilla ready for the open hardware. nowadays it's rare. I can say it's rare. Anyone here, you have a RISC-V board or computer? Anyone here? Oh, not rare, not really rare. Here, a few people that do have. So yeah, later you will realize that some dirty work you have to do for this kind of new architecture, because it's not so common. So many things you have to do. Okay, now I will introduce the things we have done for Clonezilla Live on RISC-V. The first one is since Debian had support 2 years ago, so we tried to build a live system, but actually Debian Live, the tool live build to build a live system does not support RISC-V. So we have to patch that, and you can see the details here. Yeah, we sent a patch, I think it was last year, yeah. And this Celsa Debian on Debian is a Git repository, and you can see that actually not too many files we have to change just here. Basically, it's all about the binary part. Some of part is covered x86, then ARM64, then we have to extend them to RISC-V. So yeah, if you are interested, you can find the pages file here. And with that, we create some of the, for the moment we can say it's an experimental release. And here you can see some of the experimental release on our server. And here you can see there are, so some of the time we have released some testing release for the x86, then we release RISC-V. Actually, you can see here we also have an ARM architecture. Yeah, just by the way, just to mention this. Okay, let me back to this one. So with this, we can have Clonezilla Live for RISC-V. And we released that last year, the fourth quarter, and we'll give some of the current status update about this. The first one is work well with the emulator. It's easier, I mean, for the QEMU. We later we have some of them screenshots and some of the demonstrations. And we also try to adapt to the physical machine. Cesar, you got it? Yeah. Yeah, we have a DC Roma, it's a laptop, okay? Laptop, RISC-V laptop, and actually, we have a booth there. So if you are interested later, you can, try to play with that one. But for the moment, actually, it's a little bit slow. QEMU even slower. So later when we do the demonstration, you will see it's really slow. But it works. Okay, so we have two. Okay, so for the DC Roma RISC-V laptop, actually we try two methods. The first one is to use the EFI booting. Of course, in the previous one, you have to have a U-boot. Before that, EFI booting, you have a U-boot. That's for ARM and also for RISC-V boot mechanism. But that one actually, for EFI boot, actually is failed. So we switch to another one. Later we have more details. We use just UEFI direct boot from the kernel. That's the some of the dirty work we have to do. Okay. So for the RISC with QEMU, that's easier, much easier, because some of the tools, for people to access to RISC-V, the easiest things is to use the emulator. And there are many tools we have to, related tools we have to include, but I will just mention here. We give some tests with this version 3.2.1-25, and some of tools like OpenSBI, U-boot, QEMU, or guest file system tools to do that. Later, the demonstration I will do is about we convert the Clonezilla Live zip file to a raw disk, then put in an emulator. Okay, that's the the way we have to do. And some of the command you can see here. This one is just convert the directory to a raw disk image file with the raw disk. So that's a GPT part and with a FAT file system. Okay, so we'll convert to a raw disk image. And for the QEMU, the whole command you can see here is quite long, but most of the time you just assign the CPU number, range size, and some of the things you want to assign. You just write like this one. Later, we will put the slides on our website, Clonezilla website, and later you can check more details with this one. Okay, so that's some of the screenshot. I know it's too small. So later we will use comment. Do a live demonstration. Okay, but basically I can say the steps. The first one is open SBI. It will load the BIOS, and also the second stage is continue with the UEFI booting. So it will read the graph bootloader, and it will just like a x86. You will see it's very similar, normal. You can say almost the same way to do in the x86 architecture for the Clonezilla Live part. But in the booting mechanism is a little bit different. Okay, that's some screenshot I will just show you here. That's the main menu for Clonezilla Live. If you used that before, then you know that very well. Okay, and for the RISC-V on the physical architecture, like one DC Roma. Actually, the DC Roma is made in China, and they have a RISC-V 60 architecture with 8-core CPU, and that's the SoC chip model you can see here. And we at that time we built on the version 3.2.1-21, and you can also download this one on our website. And there are some related projects. As I mentioned, there are some dirty works you have to do. Like here, we mentioned that we have to refer to some of the project, like BM4 Linux. Actually, is for like a large RISC-V architecture. The reason why we need this is because some of the drivers, some of the especially the hardware for the driver for the hardware, the module for the kernel, we cannot really build by ourselves, or we have to refer to that one, and some of the information actually not so complete. So we have just used some of them. Just the binary kernel that will be easier to switch. Use the vendor, the ones provided by the vendor. Okay. So like here we mentioned that again you put open SBI, something like that. So I mentioned we tried two way, but the first work is UEFI, then U-boot, then UEFI, then grab. That's a normal one. Universal one, we would like to make it like a ARM architecture, but later you will see it didn't work because it doesn't work. It doesn't work. It depends on hardware. Some hardware by this way you can do. Never. But for QEMU, it's quite straightforward. No problem at all. So yeah. So it's still in the early stage. We discussed about maybe the RISC-V Foundation. They should have some of the standard universal one for the older RISC-V architecture should follow this. Then everybody will be happy about this. Otherwise, the vendors still provide different ways for the booting mechanism, and everybody have to. It's really a pain. Okay, so the second work we have done is U-boot and direct boot from the kernel. Okay, and that's some of the details about this. But we won't cover too much, just give you an idea. The first one, as I mentioned, UEFI, then U-boot and UEFI. That's the first one. and we have to do some to rebuild the U-boot Open SBI, and based on the BMBoo project they have. Okay, that's special for the DC Roma laptop, and we configure U-boot procedure to make it more flexible, like the boot, parameters we have to done. Okay, we have to modify. So here is the first work. Lots of details. I won't cover all. If you are interested, maybe you check our slide later on the website or go to our booth. Okay, just like let you know, we have to adjust some of things to repack, to rebuild the U-boot OpenSBI, and we have to adjust the boot file FS or boot file system partition, and we have to unpack Clonezilla to the boot file system partition to do something like that. Okay, so that's a screenshot you can see. And actually, we put the video on the YouTube, and you can see the menu is okay, but it's actually did not detect the SD card. So in the end, we gave up. So skip this one. So we tried the second work. Let's use the U-boot and the kernel. So with this one, what we have done is also again based on the BMBoo Linux project, and we do that remaster with its kernel. Just use the kernel binary kernel provided by the BMBoo. Okay, and actually in Clonezilla Live we have a command. This one OCS Live swap kernel. It's easier for sometimes you can make by yourself, but it's easier with this one. You will switch a binary like a Debian. You want to use different kernel instead of the one we provided in Clonezilla Live. So with this command, if you have the DEV package for the kernel, then with this command you can switch that. Same thing for the RISC-V or ARM architecture. Especially this is important. It's not the kernel does not vanilla kernel does not support the hardware. You can do something like this. Okay, so that's the one I mentioned. We have to remaster the Clonezilla Live with the kernel provided by the vendor. Okay, and we replace the kernel and also the boot parameters, something like that. Okay, so here the details we have done for the. You can see that here there are many partitions we have to deal with. Okay, and for the first one, we regenerate the U-boot, the binary, and replace in the partition 2, and we have to switch something and edit the environment. Like you modify the graph configure to give some more parameters, and here we just did like this. Okay, you can see the details in this screen. Okay, and so with that we can successfully put Clonezilla Live on this machine, DC Roma. Okay, and you can see that some of screenshot is a hold on. Okay, yeah, you can see the screenshot. There's no the menu, boot menu like the one we have. It's not because it's not a grab, so we have no background, something like just direct put into the Clonezilla Live. And actually, you can use this one, save and restore the image. To back up your hard drive or something like that. Okay, that's the some of screenshot I would want to show you. Okay, and actually we save an image for the DC Roma system. And that's, if you are familiar with Clonezilla Live, with Clonezilla, the image directory contain many files, like a partition table, like the file system for every partition, like something like this. So that's we also put on our website, and you can, if you want to try, you can download this and just for your system. Okay, so conclusion for the Clonezilla Live on RISC-V. What we have done is UEFI boot procedure enhancement and we have deployed Clonezilla to the physical machine. Okay, but as I mentioned, it's actually vendor by vendor. A lot of dirty work you have to do is really a pain. And we released some of the RISC-V Clonezilla Live release, okay? And we have some of the image if you want to try on DC normal, okay? So, in the end, we can say that RISC-V really, as you can see, is still in the early stage. For x86, there's nothing you have to do like this. It's too many things you have to do. Just want to boot a machine. That's if you are, you might think it's insane. How come you have to spend so many efforts to do this? But for the things like this, RISC-V is still in the early stage. Yeah, that's something you have to do. And the emulator was well, of course, as I mentioned. And I mentioned many times, it's a pain to deal with the booting, okay, for the RISC-V on the physical machine, because that's really case by case, vendor by vendor. And you might have to customize your Linux kernel. Of course, that deal with the hardware. And actually, there are some of the small boards for the RISC-V small board. They already come with Debian or Ubuntu, so it's much easier, and you can upgrade. But still, as I mentioned, it's vendor by vendor. You have to go with the vendor the image they provided. That's still not quite universal, and because of the desktops and the server running RISC-V are not so common. So, it's not so common like x86 or even ARM architecture. So use case is not too many, okay? And that's Clonezilla Live, the support is also the experience. We still need some more experience for this, okay? So I will. Oh, okay. We have for the future work. I want to mention is we have some improvement enhancement, okay? Along with we have to do is along with the underlay operating system Debian to improve the. So we hope someday, the driver can cover most of the RISC-V machine, okay? And if that day comes and we might have some scenario like massive deployment we need, so we will, like x86, like a PXE booting, some like a server edition, and we have to port to that scenario for RISC-V. And as you can see, because RISC-V is an open hardware, so it's low the price. I mean, and because many vendor they will compete each other, and it's open, everybody co-work. So I mean, the price will getting low. It's make it viable for the budget, strapped school, something like that. So we hope someday we'll see this open hardware will be more like 86 everywhere, okay? And as you know, like RISC-V is power saving, okay? So I mean, compared with x86, so it's especially you can see why it's small board is because that one of the reasons is also the power efficiency. So in the edge device, you can see a lot. So yeah, before the daily use for the desktop or server or laptop, I mean, nowadays actually some of the vendors they also use RISC-V in the edge device. So maybe, yeah, like ARM someday, we hope that day will come soon. Okay, I will do a demonstration about Clonezilla Live with a QEMU. So. Okay, let me. I should shut it down in the beginning, because let me tell you the background. Because my laptop here is not powerful enough, so I actually connect to my desktop in my office, and I use the machine to do that. here, that's the Clonezilla Live we download from the website here. Oh no, not this one. That's the one we have here. That's the RISC-V zip file. And this is the hard drive. This is a hard drive for a RISC-V system. I mean Linux, running Linux system. And as I mentioned, we first convert the zip file. The zip file or ISO file is for the CD or USB drive. But for QEMU, it will be easier. We just switch to the image file for the raw image file for a disk. So that's a command I just mentioned in the slides to convert this one. And actually, I create a script to do something like this. And here you can see, yeah. Yeah, you can see it with this command to convert the zip file to a raw disk I just mentioned. Before that, actually, to meet the text mode, especially with a serial console or something like that, I also modify some of the graph, or to make it the background, to just some small tuning. Okay, the background and the color, and make it purpose for the put-in. Okay, so with this, I just run. I have another script that makes things easier. Just run. Okay, you can see just run like this. As you can see, the first one, it will unzip the zip file to a directory, then convert to a raw image, raw disk image. And you can see the output open SVI, then convert to the graph now. That's the graph. If you are familiar with the Clonezilla Live, that's a boot menu. Just there's no background color, something like this. So we will put the default boot menu, the first one, and it will put into a normal Debian boot procedures, a live system, especially the live system. Yeah, and as you can see, that's the rest is just a live system putting mechanism. Okay, so then we just wait for the full procedure. When we are waiting, if any question, you can present. Yeah. Yeah.
Did you build this version of UVU that's on here?
I actually no. I just use the one. We just use the one from the Debian project.
Okay.
Yeah. So that's easier. I mean, open SVI, everything from the repository, Debian repository. We didn't build. Yeah. So I mentioned it's much easier for the QEMU. Yeah.
And you said the TC ROMA is faster than the emulator a little bit?
A little bit, but not really, because
It's about the same.
we'll use the timer to check. yeah, but last time I saw that it's about the same, not really.
About the same.
A little bit.
I have one too, so.
Okay.
The TC ROMA.
Oh.
All right.
It spends about 90 seconds to put up from power on, then to display the Clonezilla. It spends 90 seconds.
Yeah.
But maybe 3 minutes about.
Yeah.
Probably.
Yeah. Okay, so get back to the familiar things we have. It's a Clonezilla Live main menu. Later you will show here now is the main menu. So I can start to make an image for my system. Okay, like this. yeah, I want to save this SSH server, something like this. And so I configure the network. Yeah, but that's not the point I want to show you. Yeah, I just want to make it work like x86 version. Okay. Yeah, I mount my SSH server and save the image. Yeah, mount, then save. It's like a big. I just give an arbitrary name, something like this. And you just go like the one you are familiar with, if you have used Clonezilla before. Okay, so yeah, basically that's the end of our talk and the demonstration. But the screen will just go continue. Yeah. So any questions?